So in some ways this next problem is easier and in some ways it's harder. What makes it easier is I noticed both equations in my system are already solved for y. So I'm ready to just take those two y equals and set them equal to each other. So I have 4x minus 5 equals 2x squared minus 5x minus 10. So from here I'm going to set the equation equal to 0 because it's quadratic. So I'm going to move over the 4x and the 5. And I get 2x squared minus 9x minus 5 equals 0. So what makes it slightly harder is just that we're last two problems, the one that was already done was GCF. The last one that we did was trinomial a equals 1. Here we have a trinomial where a is greater than 1. So we just have to remember our factoring method for that time. A lot of people, and I'm just going to show the wrong way, so don't copy this, will remember to do this, and then they'll just write, well, the numbers that add up to -9 and multiply to -10 are -10 and +1. So they'll forget, they'll rainbow, but they'll forget that we have to split the middle and do grouping, and we can really see that this is not equal to 2x squared minus 9x minus 5, right? That would give me just a 1x squared. This would give me a -10, not a -5. Okay, so make sure you don't skip part of that process. So from here, we're going to split that middle. We did say the numbers are -10x, +1x. So I'm going to write those two in, -10x plus 1x. Remember, the order doesn't matter. And then we're going to group. So here I get 2x times x minus 5, 1 times x minus 5. And so my GCF is x minus 5 and 2x plus 1. So our answers are 5 and -1/2, and those are our answers for the x's. So other thing that sometimes happens on this problem, that's already a good amount of work, so sometimes people are like, well, I'm done. You know, that looks like a decent amount of work. But remember, our original equations have y's in them, so we need to plug back in our x's and find the y's. So I'm just going to write my x's up here. We have a 5 and a -1/2. I can choose either equation, but I'm going to choose the linear one, the 4x minus 5. So we have y equals 4 times 5 minus 5. So that's y equals 15. And y equals 4 times -1/2 plus 5. So that's going to be y equals minus 5. Sorry about that. Okay, so that's 4 times -1/2 minus 5, which is going to equal -7. So writing them as ordered pairs, my first pair of answers is 5, 15, and my second pair of answers is -1/2, -7. Now, just as a side note, the x's always have to come first in the points. Now, with the method we're using with getting two y equals, we will always find the x first and then the y's, but even if I found a way to find the y's first and then the x's, it would still be x comma y in those ordered pairs. So the second thing we're going to do, and we've been doing this all year, but just to like kind of go back to that last lesson we did, remember this process, solving system of equations, was around before the coordinate planes. So they had the algebraic processes, factoring, working with quadratics, all that good stuff, before we could think about graphing these equations or graphing these two expressions. So basically, throwing in the y equals, thinking of these as functions, was something that came about once we started to look at the coordinate plane. So we're going to look at now, since we do have those techniques, we've had them for a while, how to solve this system graphically. So the first thing we want to do is just graph both of our equations, right? So my first equation is 4x minus 5. Now it is totally fine to graph this on a graphing calculator. Unfortunately, what I have to use right now, I can't necessarily pull up a graphing calculator. I will talk about it. Ask your teacher in class if you have questions about how to graph on the calculator still. So this equation I can easily graph just using mx plus b, but I could also look at a table on the calculator. So if I had a table on my calculator, points I would see would be 0, -5, 1, -1, 2, 3. In the opposite direction, I would have here and here. Okay, so I'm going to continue going just because I know that one of my answers is going to be up here at 515, right? And we know that because we solved it algebraically. But basically the idea is you might need to graph beyond what you think you have to graph to find the answers. So that's my first function, and I do have to label it on my graph. So that's 4x minus 5. My other equation is 2x squared minus 5x minus 10, okay? So the point that's super easy for me to find is 0, -10. The rest of it I would find from a table on the calculator. So looking at this, we have a point, the next nice easy point that we can find is, so the next nice easy point, sorry to pause to get a calculator there, is 1, -13. And then I have 2, -12. And from there I have 3, -7. And I'm actually going to graph up till I get to that point that I know is the intersection. Now we're going to have to talk about what we're going to do with the other intersection. So I have a 4, 2, and then a 3, 15. So I'm going to go in the other direction too. So already I have this part of my parabola. Now try to be kind of careful. What happens here is that the minimum is not on a nice integer value in my table. But since the minimum value, the low point on this graph, doesn't necessarily impact solving the system, it's not a big deal to have it perfect. Okay, don't make your graph look awful, but don't worry too much about it. So my next point is -1, -3 in the other direction. Okay. Now I know from the top what my intersection is going to be here for my other intersection, but still, I want to kind of make sure I'm accurate. We're going to talk about how to find it. Like, let's say we didn't know the algebraic answers. I'm just getting one more point, 2, -8. Okay. Then we do have a way that we can always find the intersections. So I have my two graphs down. The point that I can already see is the point 515. Right? And then there's another point in here, and as I said, I'd have to be really good at graphing to know where that crossed because it's not currently in my table, right? We know that's the point -1/2, -7. So what you can do on your calculator, I'm going to write it here since I can't bring up the calculator. You can press second calc, so that's where we have the minimum and the zeros and the maximum that we've already done. And then you're going to choose number 5, intersect. Okay, and actually on this it's going to ask different questions. So it's not going to ask left bound and right bound. It's going to ask first curve, second curve, guess. If you do nothing else and just press enter, enter, and move over to where you want to guess, and then press enter. So basically you're pressing enter 3 times and just make sure the last enter you're near where you want to find. That will give you the point. And on your calculator, it's going to give you -0.5, -7, which is that intersection, right, just as a decimal. So if you're on Desmos and you graphed these two functions, it's just going to pop up. It's actually just going to show that dot, you hover over it, and it's going to show you what it is. So that's even easier. If you're on a graphing calculator, it's a little trickier. Now, to answer this question, make sure somewhere, even if you draw these beautiful graphs, that somewhere you write the intersections and make it super obvious that you know that they're the answers, okay? So this is just another case of where we can see that the algebra agrees with what we find graphically. There are 2 ways to solve systems. It's a great way to check, even if you didn't draw a graph. If you solved something algebraically and did graph it and just kind of looked at the graph, you could say, yeah, my answers make sense. Things you need to write, equations, label those functions, right? And the points are accurate. And then label your intersections and rate your intersections somewhere so it's super clear that you know that's your answer.